Alrighty. A potato is launched at 31 meters per second at an angle of 54 degrees above the horizontal on a level field. What time is the ball in the air? Okay, so this is a situation like this, right? And it's 55.4 is like launching like that, right? And the thing's going to go nice high trajectory like that, right? Okay, so this is 31 meters per second. Right, and then this angle here is 55.4. Okay, so I'm just going to do the components of this thing, right? That is the trig angle, right? So my initial velocity in the x direction is 31.0 cos 55.4, and my initial velocity in the y direction is 31 sine. All right. Okay, so here we go. Turn on the calculator, checking to make sure that I'm in degrees. Indeed I am. Okay, so 31 cos 55.4. I'm going to store that in A, by the way. 31 sine 55.4. I'm going to store that in B, just by the way. A proposito. Okay, here we go. Okay, so 17.603 is this guy. And then this guy is 25.517. Okay, so let's see. I just did this without really thinking because you always have to do that with angle magnitude vectors, right? Then this guy's 0, this guy's negative 9.81. Let's see, because it can't accelerate the final velocity, any velocity anywhere horizontally is 17.603. Okay. And then, okay, so this is just an up and down. It's going to land at the same elevation. So this is 0. The final velocity here is minus 25.517. And then that's the key there, right? We can find the time using this. V equals U plus AT. So I'm finding the time on the vertical side here, right? You can also use, by the way, UT plus 1 FAT squared, and that will also give you the time. It's kind of cool. But I'm just going to use this guy because I think this math is simpler. Okay, so here we go. Minus 25.517 is positive 25.517 plus negative 9.81 times t. Now, you know, if at this point you're just like going 2 times that vertical velocity divided by 9.8, good for you. All right, so times 2 divided by 9.81. 5.202, 2022, I'll say 2023 seconds or something like that. Is that right? 5. Yeah. And then of course that goes across 5.2023. That's when it hits the ground. It stops moving horizontally and it stops vertically, right? Okay, and then I think we can find our S here. S is UT. And I'm doing this on the horizontal side here, right? So it's 17.603 times 5.2023. For me, by the way, that's just, I've stored the time in t. So let's see, alpha A is my 17.603. I go that times alpha t. I get 91.5758, 91.58. Meters, right? So our answers are there, 91.6 meters with sig figs. 5.2 seconds, 5.20 seconds, right? So 5.20 seconds with sig figs. So that is it. So we got the time in the air, distance it goes. You can, of course, check this range with the range equation, right? Make sure you've got it right. All right, good enough.